Hey everyone, in today's lesson we're going to be completing the unit here. So we're going to take everything that we've learned up to this point and we're going to be putting it all together. So previously we had talked about SOHCAHTOA, so a way to remember what goes with sine, what goes with cos, and what goes with tan. So remember, you have sine is opposite and hypotenuse. Then you have cos is adjacent and hypotenuse. And then you have tan, which is opposite and adjacent. So you have SOHCAHTOA is an easy way to help you remember what is sine, what is cos, and what is tan. So hopefully that'll help you through this lesson here as we put everything that we've learned together. Now, in the first one here, we're going to be looking at calculating for an angle. So we are going to first, though, change this because this is going to be a value that is greater than 1 and it won't work for sine. So what I'm going to get you to do is change this to a 1. So we have sine A equals 1 over 2. Now, what we need to do to solve for this is we need the inverse. So we need sine -1. So the way that you do that on your calculator, remember, is second function and then sine. So you'll get sine with a -1. And then what we need to do is we need to solve for 1 divided by 2. So you can either do that before, which will give you 0.5, or you can put a bracket and then do 1 divided by 2 and then close that bracket. If you don't do the brackets, it will not calculate it correctly. So either you do 1, so you can put in sine -1 and 0.5, or you can do sine open bracket 1 divided by 2, close the bracket, and then you should get an answer that equals 30, and your unit would be degrees because we're looking for an angle here. So it would be 30 degrees. Now if we move over to cos B and we have 1 over 2, we want to follow the same thing here. So when you're using your calculator, you're pressing second function. So you're doing second function cos, which will give you cos -1. Then you want to do an open bracket, 1 divided by 5, close the bracket, or you could do 1 divided by 5 beforehand to get that decimal and then use that value. And then what your answer should be is 78.5 degrees. Now we're going to round that up to 79 degrees so that we have it as a whole number. So we're getting a whole number of 79 degrees. Now we have tan C of 6. So we want to do tan -1 and 6, and we're going to get an angle of 80.5, which will turn into 81 degrees as their final answer. Now remember, degrees is our unit for this, so make sure that is included in your answer. Now for the next question, it says, when two sides are already known, then the angle can be found using inverse trig ratio. So what we were just using above, we were using that inverse, so the -1, to calculate for this. Now we have our unknown angle at our top here. We have our 90 degrees in the bottom left, so that means that's our hypotenuse. So our 12 is going to be our hypotenuse, and this 10.4 is going to be our opposite. So we have an opposite and we have a hypotenuse. Well, that means we're going to be using so. So sine equals opposite over hypotenuse. So we have sine theta equals opposite over hypotenuse. So we have sine theta equals, our opposite is 10.4 over our hypotenuse, which is 12. Now we want to do the exact same thing as what we were doing above there. So you can put that in brackets and you do your second function. So you'll get sine -1, so your inverse, and then do 10.4 divided by 12, and we're going to get an answer of 60 degrees. So our missing angle there would be 60 degrees. Now if we look at this one here, we have our angle at the bottom. We have right across, which would be our opposite, and then our 90 degrees is pointing to our hypotenuse. So this would be our hypotenuse, which we don't have, but we do have our adjacent. So what we have is our opposite and our adjacent, and that means that we're going to be using TOA. So it's going to be tan theta equals opposite over adjacent. So remember, if you can't remember exactly which one it is, look at, okay, we have our opposite and adjacent. You're going to look up here, and well, sine is opposite and hypotenuse, so it won't work. Cos is adjacent and hypotenuse, so it won't work. So then we have opposite and adjacent. Well, that's our two things that we have, so that's going to be our formula that we're going to use to calculate. So we have tan theta equals opposite over adjacent, and our opposite, so we have tan theta equals our opposite, which is 5.6, over our adjacent, which is 12. Now we want to do our inverse, which means we hit second function tan. So we have tan -1, and then we're going to be doing 5.6 divided by 12, and this is going to give us an angle of 25 degrees. So this is going to be our angle for this missing spot right here. Looking at example 3 now, it says to determine the angle indicated in each of the following. So we have an example where a guy wire 8.5 meters long, so we have a wire that is 8.5 meters long, is attached 5.7 meters from the base of a pole. So it's 5.7 meters from the base of a pole. We have two measurements that are given to us here. So if we have a pole and we have to make a triangle, we know that. So we have our triangle. Now I'm just doing a rough drawing. I'm not doing it to scale. It's just to help us solve this problem right now. So it says the guy wire, which is 8.5 meters long. So this is going to be our wire, which is 8.5 meters long, is attached 5.7 meters from the base. So if this is our pole, it's 5.7 meters from the base, so this would be 5.7 meters. Now, what we have to do is find the missing angle at the bottom here. Theta at the bottom, what we have, well, we have our 90 degrees here, so this means this is our hypotenuse, and our angle is right next to our measurement here, which means we have our adjacent. So what we want to think about is what ratio are we going to be using? Well, if we look up at the top for SOHCAHTOA, we have adjacent and hypotenuse, meaning we're going to be using CA. So cos equals adjacent over hypotenuse. So we have cos theta equals adjacent over hypotenuse. Cos theta equals, my adjacent is 5.7 over my hypotenuse, which is 8.5. Now we want to do that inverse again. So we're going to have cos -1, then in brackets 5.7 divided by 8.5. Remember, those brackets are key. If you don't have the brackets, you're going to get the answer wrong. So make sure you include those brackets when you're doing it, or do the 5.7 divided by 8.5 beforehand. Then what our answer is going to end up equaling is 47.8, but we're going to round that up to 48 degrees. And don't forget your degrees, because that's your unit for this. So 48 degrees is that angle at the bottom. For B, we're looking to calculate for the angle of depression. And it says that it's from a point that is 10 meters downhill. And we're looking for the horizontal, or we have a horizontal that is 6.9 meters. So we have a measurement that is 10.1 downhill, so it's our 10.1 downhill. We have a horizontal, so it's going left to right there, which is 6.9 meters. So we have 10.1 meters and 6.9 meters. We're looking for that angle of depression. Now remember, that depression angle is going down, so we're looking at our theta, which is going to be right there. Now, our 90 degrees would be here, meaning that that is our hypotenuse, and this angle right here is going to be our adjacent. So we have our adjacent and our hypotenuse, which means we're going to be using ka, which is cosine equals adjacent over hypotenuse. So we have cos theta equals adjacent over hypotenuse. And looking back at our diagram, we have cos theta equals adjacent is 6.9 over hypotenuse is 10.1. We'd have cos -1 inverse, and you're hitting second function cos to get that. And then you're doing in brackets 6.9 divided by 10.1. And this is going to give us our angle. And our angle of depression is 47 degrees. And that would be our final answer for that. Now we have one more problem here where we're looking at example 4. The Polaravik-Kavlu Friendship Center in Rankin Inlet, Nunavut is a place where elders share their skills and knowledge with young people. Tagak is one of the maintenance people who cares for the center. Her current job is to replace the center's front steps. She knows that the distance between the ground and the landing is 0.86 meters, and that the stairs end at a point 1.2 meters from the edge of the landing. So they've included a diagram here where we have the ground on the bottom here, and then we have our landing up here, and we have 1.2 across the bottom for our ground of the stairs, and then we have a height of 0.86 meters. What will the angle of elevation from the bottom to the landing be? So we want to find out what this angle is going to be right here. Remember, we want elevation, so the angle is going to be going up. So what we have included for us is our opposite, and we have our adjacent, because this would be our hypotenuse because it's across from the 90 degrees. So we have our opposite and adjacent, meaning what we're going to be working with is tan. So we're going to have tan theta equals opposite over adjacent. Next, we'd have tan theta equals, well, looking back at our diagram, our opposite and our adjacent. So we have opposite over adjacent, 0.86 divided by 1.2. Now to solve for our angle, we're going to do tan -1, so our inverse, and then we'd have an open bracket, 0.86 divided by 1.2. Close that bracket, And what we're going to get for our angle of elevation is 36 degrees. And that would be our final answer for our angle of elevation. Now that brings our lesson to a close here, and we've gone through all of the different concepts so far. The most important thing when you are doing this on your calculator is to make sure that your calculator is always in degree mode. So make sure it says DEG at the top of your calculator. Otherwise, you're just following the steps all the way through, and you can use SOHCAHTOA to help remind you of which parts go with which ratio. Other than that, if you have any questions, send me a message on Teams, and you can have a great day.